So let's review a little bit. By the way, let me ask you this. If I have a number line, and here is 2, and here is how about 13? And I have this graph. Okay. Go ahead, everybody, draw this. If you saw this graph, okay, which numbers am I talking about? Somebody give me a solution to this graph. In other words, so for example, which x am I talking about? So x could be what? I'm going to write as a set. X could be Aaron. Okay, if you said that, give me one of them. 5. Oh, very good. Any other? How many numbers are there, by the way? Yeah, there are many. Okay, somebody can raise your hand. Yes, sir. 2.2. Sure. Any others? Yes. 8.5. Sure. 8.5 belongs to this graph. There are many. There are infinitely many. Okay. You can, Julia, can you then give me one? 12.5. Sure. Any others? Somebody that didn't go. Jake? Pi? Sure. Yes. Pi is about 3.14 something. Pi is in, yeah. Pi is between 3.1 and 3.4. So it's in there. Yeah. 7 is one of them. Yes.
5.5.
5.5. Can I write 5.5? Yes, sir. 3.002, sure. What about 2? And I'm going to put dot, dot, dot. How many more are there? Infinitely many. Julia, is 2 a solution to this graph? No, it's not. Oh, I'm sorry. Yes, it is. My bad. I'm lying. Julia is right. No. What about 1.9? No. Okay. What I meant to say was I forgot to do this first. Sorry, guys. What if I had instead of 13? But what if it was open like this? Okay, now, what about 13? Is 13 my solution? 13 is. How many say yes? No, it's not. 13 is not. I have open circle now. That means you could get really, really close to 13, but not 13. What about 13.1? No. What about 12.999? Yes, that one works, but not 13 because it's open circle. You know what I'm talking about? So, question?
What's that number after 12.5?
Pi. Yeah, don't worry about it. Pi is a letter that we use to represent 3.14 something. Okay, anyway, guys, so Hasten, is it possible for me to write out all the numbers that between 2 and 13? It will take forever. No, I can, because there's so many. So guess what? We have come up with ways to represent this. Instead, so this is not good enough. This doesn't tell me all the numbers, right? So to represent this graph, guess what? We say all real numbers. Write this down. What? What is your, remember verbal phrase that we talked about before? What would be the verbal phrase for this graph? All real numbers between, Julia? Between, that's the key word, between. 2 and what? 13 except 13. We can't, because if you say 2 and 13, right, you are including both of these endpoints, right? So you have to say, or actually, no, I said it wrong. Whoops. If you say between 2 and 13, is 2 and 13 included in this solution? No, it says it's between 2 and 13. So 2 and 13 is if I had this graph, it'll be just this. It'll be like this. So how would you describe this? Guess what? You have to say, if you want to include 2, anybody know what to do? Yes. Including, my bad. Yeah, including. This is how you say it. If you don't indicate. So if you want both open circle, you don't need to say anything about including, because if you say something is between two numbers, we don't include those endpoints. Does that make sense? But if you want to include those, everybody okay with that? Now notice what words we use. We said and. So all numbers between 2 and 13. Okay, anyway, so never mind. Okay, so any question there so far? Now, if you remember from last time, the way we get this graph was by combining two inequalities. Could we think of this as combining two inequalities? So here is 2 and here's 13. Remember which inequalities do we have? If you had this graph, does anyone remember which inequalities will give you this sort of graph? First of all, do you think we're going to need something like this, where 2 this way? What's another one that we need? Anybody? Yeah.
13 to the left.
13 to the left. And open circle.
I think I know what.
Yeah. What inequalities does the black one? Let's just look at the black one right here. What is this inequality? This is x is what?
X.
Oh, by the way, I'm kind of weak. I'm just doing too much at once. My bad. So, by the way, another way of representing, my bad guys, let me go back to this. Another way of representing this is using x in the middle and 2 less than sign. What goes on the left? If you want to write all real numbers between 2 and 13, we write x is between what? 2 and x is 13 and like this. Do you guys remember this? This compound inequality represents the verbal phrase. This way. Do you see why I have 2 and 13? Do you see why it's less than or equal to right there? Doesn't it? Because we want x to be between what? 2 and 13, including 2. That's what the verbal phrase is. Does that make sense? No? Well, okay. That's fine. If it doesn't, let me explain this to you right now. So, this is what I wanted to show. Okay, so what does this... So, remember, this is what we want to show, right? This inequality. Right? So, first of all, how do you represent this? All real numbers that's greater than 2. X is what? X is? Yes.
X is greater than or equal to 2.
Very good. How do you represent this red one where it goes to the left of 13? X is? X is, anybody know what the red? This is all real numbers less than 13. How do you represent that using this? Yeah. X. Yeah. Do you remember what word goes in here so that it describes this thing? You need n. Whoa. That's not how you spell n. I'm sorry. N. Okay, it's kind of weird when I capitalize it. So, why do you suppose I need n? What does n mean? Yes?
It means like it's one equality, but it also it's another one.
Yeah, it's got to be solution for what? Yeah. That's what and means. So if I have, so let me separate these. Is that okay if I separate them? Let's look at the black. Here's 2, here's 13, right? It goes to the right side of this. Here's one inequality, right? Let me show you the red one. The red one looks something like this. Here's 2, here's 13, and it goes to the left. What are the solutions for the black one only? Let's say that I'm just looking at this inequality by itself. Okay, let's just look at this one. X greater than or equal to 2. Can somebody tell me what the solution for this inequality looks like? Yeah.
Like verbal phrase is just
Verbal phrase.
all real numbers greater than
All real numbers greater than?
13.
No. This one? This represents all real numbers greater than 13?
All real numbers greater than
2. All real numbers greater than or equal to 2. Right, Jake?
Yeah.
Okay, then, and Robert? What about this? What's the verbal phrase for this one, Robert? The red one.
All boundary number is
less than 13. Now, if I want solution for both, do you see why it gives you this graph? What would the solution for both be? By the way, is 2 a solution for both of these inequalities? What about -1?
No.
Well, is it a solution for the red one, -1?
Yeah.
But is it a solution for the black one?
No.
No, you see? What about 14? Is that a solution for both?
No.
No, it's a solution for,
2.
well, not
The
2.
black one.
The black one, the x greater than -2, but not solution for the red. So when I say and, I want the solution for both. In other words, this is a solution where both of them overlap. Isn't that where they overlap? Right, guys? So when I use the word and, I want the solutions where it's true for both. Right? Solution for both means it's got to be true for both. Right? Does that make sense, guys? So that's what we worked on last time. Hello? So let's do an example. Example 1. If I set this, I would like you to give me solutions for graph solution for x greater than or equal to 0, and this is a keyword and, because if it's not and, if it's there's something there's another word we could use instead of and. We could use something else with or. That's next time, okay? It'll look different. So if I have x greater than and x less than 4, everybody go ahead. Can you guys graph what this? So this is called compound inequality. Compound just means more than one, okay? So we have inequalities more than one. What would this look like? Everybody go ahead and try. I would like you to now work as a group. I'll give you time, okay? Go ahead, everybody try. I'll go around and take a look. So first of all, guys, did you get this graph for x greater than or equal to 0 this way? Oh, where's 4, by the way? Here's 4, right? 0 and 4. X is less than 4. What will be the solution for both of these? Here's 0, here's 4. Anybody?
Color
Yes.
Solid.
Solid at 0 and what about 4? Is it open or solid? It's open because this is open, right? So how do we say this? X is what? Between 0 and 4 like this. How many people understand? Does that make sense? Okay.